Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel, everyone. I hope you guys are doing great today. So this is episode 8 of the series on how to do the derivative find the derivative or solve for the derivative of the function using product rule, actually just trigonometric function. So welcome back. In this particular episode, we have the function tan x multiplied by cotangent x. And as you guys know, like the first 7 videos explained it to you, where since we're doing trig functions, we're going to be breaking the information down. In this particular video, tan x multiplied by cotangent x. So we can see that we're going to apply the product rule because tan x is the first subfunction and cotangent x is the second subfunction. Therefore, we can say from this that we have f of x to be tan x and g of x to be cotangent x. And since that is the case, we have f of x to be tan x and g of x to be cotangent x. We know that this would have to follow some form of derivative rule since we can properly express. Now, because we have the two subfunctions multiplied by each other, we're going to apply what is called the product rule. And applying the product rule means the derivative of the first subfunction that we're given, in this case tan x, multiplied by just the second subfunction plus the derivative of the second subfunction, right, multiplied by the first subfunction. So that is basically what is going on here. So now we can go on to solve it. So here we have the derivative of tan x multiplied by cotangent x equals to the derivative of f of x, which is tan x, multiplied by g of x, which is cotangent x, plus the derivative of g of x, which is the derivative of the cotangent x, right, multiplied by just the first subfunction by itself, f of x, which we know from here is multiplied by tan x. So now that we've established this part of the information, we have to start solving, because the first thing is for us to make sure we apply the product rule, and after application of the product rule, we have to start differentiating, right? So now, what is the derivative of tan x? If you're watching this video for the first time, you probably already know this, that in my videos, whenever I teach trig functions, I make sure to have a page dedicated to trig notes. This is basically the name of the page, trig notes. So if you've watched my videos on chain rule that involves applying chain rule to trig functions, or applying chain rule applying quotient rule to trig functions, or in this case applying product rule to a trig function, so this is going to be something that is familiar to you. So in this case, you can see that we have trig expression to the right, like sine x equals to 1 over cosecant x, cosecant x equals to 1 over sine x. All of this information right here to the left of the page is called trig expression. Okay? Then all this information that I'm boxing in red, sine square x plus cosine square x equals 1, and cosine x square x plus 1 equals cotangent square x plus 1 equals cosecant square x. All of this is called trig identities. So this is basically trig identities, right? And then the last thing that you should see is anything that you have in this page that is written in red pen is what you would call trig derivative. So this is it. So I wanted to teach you guys or show you guys this part. Please, if this is the first time that you're watching any of my videos and you've not been following the series, that means this is the first time you're probably seeing this page, please pause the video and write all of this information down. The trig expression part, the trig identity part of the trig notes, as well as the trig derivative part. So, now that we know that this is what we have, now they said we should find the derivative of tan x, right? We know the derivative of tan x to be, if we look here, we know the derivative of tan x is secant square x. So here, I'm going to change up the color. So we have secant square x, okay, multiplied by cotangent x, because that's what we have here, plus, what is the derivative of cotangent of x? The derivative of cotangent of x in this particular case is, where is it? The derivative of cotangent of x is negative cosecant square x. Negative cosecant square x. Negative cosecant square x. So you have negative cosecant square of x multiplied by tan x. So basically our answer is now going to be secant square x, okay, cotangent x minus cosecant square x basically tan x, right? So this is basically the answer to the question we just asked, the derivative of tan x multiplied by cotangent x. But guess what? This is not the end of the video. Now, because we're dealing with trig functions, our work can also be broken down further. You know how in mathematics, if it's possible for you to cancel things out or factor things out and then cancel it out, or replace particular terms with simpler terms to make your entire answer, to make your solutions easier, that's the same thing we have to apply. We're dealing with trig functions, and this answer, even though it is correct in its own right, is too complicated for us to leave. Now, if you put this in when you're solving it, your teacher could give you the full points, but it's also possible that you might not get the full points because they may be looking for a more simplified answer. Okay? So we're going to rewrite what I have in the black box here, which is, we're going to rewrite it as secant square x cotangent x, okay, minus cosecant square x, okay, tangent x. So the first thing you have to do is, we're going to break down all of this, right? What did we say when we're trying to break this down? My goal is to break down all of this information in terms of sine and cosine, okay? In terms of sine and cosine. So the first thing we have is secant square x. When you look at this trig expression part of the trig note, what did we say trig expression was? Here we have secant square x. But we see here that secant x is the same thing as 1 over cosine x, right? If that's the case, we can now change it here. Oh, now we just don't have secant x. We have secant square x. Therefore, we can call this 1 over cosine square x. Okay? This is one part of the information. Now we have cotangent x. If we go to our work, we have cotangent x here. What do we know cotangent x to be? We know cotangent x to be cosine over sine. We also know cotangent x to be 1 over tan x, but we don't want that. We want a more simplified information, and we want to do it for the purpose of this video, for the purpose of this series, and for the purpose of complex question solution to be broken down. We're going to stick to cosine and sine. So we have cotangent equals cosine x over sine x. So we're going to put that here. Cosine x over sine x, okay, minus cosecant square x equals what? Well, we know cosecant square x is going to be negative. Cosecant square x is the same thing as what? Well, cosecant square x is the same thing as what? Again, cosecant x is the same thing as 1 over sine x. So therefore, cosecant square x is going to be what? It's going to be 1 over sine square x, right? And now let's go to the last one. We have tan x. What would tan x represent? If we go back to our work, we see tan x is the same thing as 1 over cotangent x. Yep, that makes sense. But we want to leave our work in terms of sine and cosine. We see that tan x is the same thing as sine x, right? Over cosine x. So we have tan x equals sine over cosine x. So we're going to put multiplied by sine x over cosine x. And that's our work so far. So what we need to do now is cancel this out, cancel this out, cancel this out, cancel this out. So what we eventually have in our work is we have 1 over cosine x, okay? And you have 1 over sine x to here, so multiply that 1 over sine x, okay? Interesting. Minus 1 over sine x multiplied by 1 over cosine x. So what you eventually have is going to be 1 over cosine x sine x minus 1 over cosine x sine x. So what you eventually have is you have a positive term here and you have a negative term here. So what you end up is you're going to cancel it out, and canceling it out is the same thing as basically this information here. Don't be confused by the way it looks complicated. It's not that complicated actually. What he's just trying to say is, oh, you have this, you have that. So it's just like saying plus 1 minus 1 is the same thing as 0. So these two terms together can cancel out each other, so your answer here is actually 0. Now imagine if we had just left the answer as sine square x multiplied by cotangent x minus cosecant square x multiplied by tan x. It's a lot of information. You have to find a way to break things down so that it's not going to be as difficult as it would naturally be for you, right? So that is something that is important for you to know. The way our answer is left as 0 is better than you having it this way, but both of the answers are actually correct. One answer involves you applying the product rule, and that's about it. The other answer involves you simplifying the answer for you to get 0. So now I'm going to teach you guys a shortcut method. And remember that we are given the question tan x, right, multiplied by cotangent x. Since this is what we're given, we can call this this tan x multiplied by cotangent x. This is a function that we're given. Before we apply the derivative to it, we have to first of all say, what is tan x, what is cotangent x? If we want to find it in terms of sine and cosine, we can say sine x multiplied by cosine x multiplied by cosine x divided by sine x. I think I made a mistake when I said x. Tan x is the same thing as sine x over cosine x. Cotangent x is the same thing as cosine x over sine x, right? So that's what we have here, right? You have tan x, the same thing as sine over cosine. Cotangent x is the same thing as negative cosine over sine x. That's what the thing is here. So next thing we can do is cancel stuff out. Sine divided by sine, cosine divided by cosine. So what you end up is 1. So f of x, therefore, is equals 1. And when we have to do the derivative of f of x, in this case, which is 1, we know our answer is going to be 0. So this is a shortcut method. And you can see that we got our answer to actually be 0. Here you get the answer to be 0. So the shortcut method actually confirms our product rule application. So I hope everybody has learned something today, and make sure you ask your questions and put it in the comment section. But you should also check this description box, because that's the best way I can communicate with you guys aside from what is in the video, of course. Make sure that you see the description box. If you have any questions first before leaving the comment section, because the information is probably in the description box, and if it's not there, please leave your information there. If you like this video, please give it a like and share with your classmates or with other people that you know are studying calculus. And make sure you keep on watching the videos in the in the link, as well as on my channel. If you guys have suggestions, please put it in the comment section. And most importantly, if you really love my channel and you've been learning, don't forget to love that subscribe button by clicking on it. Thank you very much for your time. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.